This is Algebra Step by Step. Let's learn the distributive property. Our last lesson we learned about PEMDAS, so let's begin there. Take a few moments, pause the video and answer these questions, and when you come back I'll share with you the answers. Well, PEMDAS, that's just the order of operations. It's our instructions, which is why it's essential. And with the PEMDAS, just remember, we always start with the grouping symbols. So we start with the grouping symbols, and we do what's inside the grouping symbols. Then we move on to exponents. Then we multiply, divide, and then we add and subtract. This all works the same direction that we read, which is from left to right. Now let's simplify the following. Well, 3 times 4 plus 6. 4 plus 6 is 10. So you should have got 30. Here you've got 3 times 4, which is 12. And then you have, I'm going to add 6 times 13 to that, which would be 18, which is 30. Here, 10 times 3 is 30. You've got 2 plus 3, which is 5. 6 times 5, well, that's 30. We have 2 squared, so you got 3 times 4. To that, we're going to add whatever 2 times 3 is. So 2 times 3 is 6. Gives us 12 plus 18. Once again, that's 30. But did you notice? Well, you should have noticed all the answers were 30. And the key here is we've got 30 by doing a bunch of different things. And one of those things we saw up here is actually the distributive property, which we're going to learn about right now. So our learning objectives, well, we're going to learn how to define the distributive property, and then you're going to apply the distributive property to simplify expressions, and then finally you'll be able to explain how it works in general. What you need to know is PEMDAS, which we just reviewed. PEMDAS, that's our order of operations, order of ops. If you're confused with that, go back and work some more PEMDAS problems. You need to be able to add, like 2 plus 3 is 5. You can do that, you're good. You need to be able to subtract, so if you can do 4 minus 3, you're ready to move on. If you can multiply, say 6 times 7, well, that's 42. And if you can divide, 10 divided by 2 is 5. If you can do these things, you're ready for the distributive property. So let's get going. What you need to know some terms is your coefficient. If you have 2x, your coefficient is the constant or the number. In this case it's a constant, but it's whatever number is written in front of your variable. Your term is a plain number, it's a number, or a product of numbers. So x would be a term, 3x would be a term, 4x plus 7 has 2 terms, 4x is a term, 7's a term. Like terms have the same variable raised to the same power. So once again, like terms are the same, have the same variable and they're raised to the same power, like this 3x, 4x, and x. Those are all like terms because they have the same variable and the same exponent of 1. Y cubed and 7y cubed are the same variables because they have the same terms. Exponent, well, that's just a power. And to distribute, that means you, so if you have 2, x plus y distribute means to give away. So you're going to give that 2 to this x, and you're going to give it to the y. And you got to give the same thing to everybody when you're distributing things, especially in a math class. So here's an example, and we'll just kind of clarify some things. You got 4 times the quantity of 3 plus 2. Well, 3 plus 2 is 5. 4 times 5 is 20. The next example is we're going to take the same numbers and we're going to distribute it. So we're going to distribute that 4 to the 3 to get 4 times 3. See right here in this red box? 4 times 3. 4 times 3. Now we're going to distribute it to that 2 to get 4 times 2. Well, 4 times 3 is 12. 4 times 2 is 8. And when you add them, you get 20. There's 2 ways to distribute. We got the box method and we got the arrow method. The box method is we're going to use boxes to organize our work. So here, you'll draw a rectangle. In that rectangle, you put 5 times 3. And you draw another box. And you'll put 5 times 8. Then whatever 5 times 3 is, which is 15. And then you'll do 5 times 8, which is 40. You're going to add 15 and 40 to get 55. So with the box method, you draw a box. Just a recap here. Then this box here, get your 5 times 3. This box here, get your 5 times 8. You multiply. And then you combine what's ever down here, which in this case is 55. Next one, if you have 5 times 3, so we want some boxes. First box is we're going to put 5 times 3. I'm going to erase these boxes here. It looks kind of sloppy. So now we've got 5 times 3. We're going to put another box next to it. What do you think is going to be in that next box? 5 times negative 8. Some of you people out there didn't say negative, but you got to remember that minus is also a negative 8. So when you got inside your parentheses here, these numbers go together. So a positive times a positive is a positive. 5 times 3 is 15. Positive times a negative is a negative. So we know this number here is going to be negative. So the previous slide I mentioned that we're combining. So here you're combining 15 and a negative 40, which is the same thing as 15 minus 40. Well, 40 minus 15 is 25. But since that 40 is negative, the answer should be negative 25. And it is negative 25. So let's clean this up. So that's the box method. I like the box method just because it helps me keep things organized. So let's do one more here. So the first one, notice we've got a negative here. And that negative goes inside the box. Then we have negative 5 times negative 8. We want to pay attention to our negative signs. Sometimes I'll circle them. And then I'll circle them here just to make sure that I'm not making a mistake. Well, what's 5 times 3? That's right, 15, and a positive times a negative is 15. Next one here, we've got 2 negatives. What's a negative times a negative? That's right, a negative times a negative is a positive. And what's 5 times 8? Perfect, it's 40. Now, what are we doing with this negative 15 and 40? That's right, we're combining. And I like to use the word combining just because it's going to be useful later on, because adding and subtraction in some ways really doesn't exist. we're either combining positive numbers, which is what most people think of when you think of addition, or if you combine a positive and a negative number, that's what a lot of people think about when they think of subtraction. But if you just think you're combining positive and negative numbers, it's just going to make your work easier. So now we have 40 minus 15. What's 40 minus 15? All right, that's right, it's 25. So that's the box method. One more box method problem. What's different about this one? That's right, somebody pointed out there's a negative x. Still going to work just the same even though there's a variable. So we're going to start off at negative 5 times 3. And just think to yourself, is that answer going to be positive or negative? Now we have a negative times a negative. But it's going to be a negative 5 times a negative x. Well, okay, that's right. Negative 5 times 3 is 15. Negative 15, good job. Negative times a negative is what again? That's right, it's positive. And then what's 5 times x? That's right, we don't know what x is, so we're just going to leave it as 5x. And keep in mind, this 5x here, it's a term. This negative 15 is a term. We're going to combine these terms. Are these terms, are they like or unlike? That's right, they are unlike. So if numbers are unlike, if your terms are unlike, you just got to write it as an expression, or in this case, an equation. So now we got negative 5x minus 15 is equal to 25. Our next lesson, we're going to move on eventually and solve equations. Eventually, you'll be able to solve this. Some of you guys can do it right now. But for today, we're just trying to get to here. Here is our goal. Here is our goal. So you're good if you can get this. We'll worry about that next step of solving later on. The arrow method, well, some people like the arrow method. You draw an arrow from 5 to 3. Well, 5 times 3 is 15. Make a little notation up there. Next, you're going to draw an arrow from that 5 to that 8. What's 5 times 8? That's right, 40. So we've got 40. What operation are we doing here? So we are adding. So in this case, we are combining two positive numbers. So it's just addition, right? So what's 40 plus 15? If you said 55, you are correct. There's another problem. Notice how is this problem different from the previous slide? What was that? Yeah, that's right. It's negative. So we'll go ahead and circle that, kind of highlight it there, because I want to remember at some point I'm going to have a negative number in my work. Well, once again, we draw our arrow from the 5 to 3. What's 5 times 3? Good, 15. And now we're going to draw an arrow from what two numbers? Good, yeah. We're drawing the arrows from 5 to 8. And what's 5 times 8? 40. But remember, it's a negative 40 because of that negative sign. So we are combining a positive 15 to a negative 40. So what is negative 40? If you're at negative 40 on the number line, and you go forward 15 units, where are you? Oh, yeah, okay, good. Yeah, that's right. You're at negative 25. So which method do you prefer? Pause the video, discuss it with your your small group, the person you're working with. There's not a right or wrong answer. Some people like the box method. Some people like the arrow method. It does not matter which method that you use. What you want to do is just make sure that you get the right answer. Now, with algebra, especially when we start solving equations, we want to do a lot of work with variables. Just keep in mind, it's going to, the beauty about mathematics, it works the same no matter what you're dealing with. So here we've got some terms, 2x, negative 2. We're going to do the box method. So the first thing we're going to do is the first box. We're going to have 2 times x. What do you think is going to go in the next box? Well, that's good, yeah. 2 times negative 2. But what's 2 times x? Perfect, yes, 2x. Positive 2 times a negative 2, is that a positive or negative number? Yeah, there you go, it's negative, and then what's 2 times 2? 4. Now think about this, as our final answer, is it going to be a single term, like 4 or 3x, or is it going to be an expression with multiple terms? Think about it. And then you should have realized that it's 2x minus 4. We can't solve this because there's no equal sign. This is just an expression. You want to remember, you simplify expressions, but you solve equations. So there's nothing to solve here. And once again, today's goal is just to distribute. So we're not trying to do any more than this, because we want to learn one thing at a time. Because if you learn one thing at a time in algebra, when you get to the end, it's going to be super easy. We're still working with variables. What's different about this problem than other problems we have worked so far in this unit? That's right. Somebody pointed out it's got a variable out front. Is that going to change any of the rules of math? No, it's not. So we're going to write our boxes. What should go in the first box? First box should have just x times x. What should go in the next box? What do you think? X times negative 2. Don't forget that negative. So again, I always like to circle them just so I can remember them. And then what's x times x? X squared. Then what's x times negative 2? So it's negative 2. Are these the same? Are these like terms or different terms? Somebody said like, somebody said different. All right, give me your final answer. They're unlike, so there's nothing we can do with unlike terms other than just write it as an expression. And it's okay to have an expression for an answer. I think this is one of the biggest challenges people have when learning algebra or higher level math is, they're so used to getting a constant or a number, like 7 or 7.2, they get ordinary numbers. But it's okay to get expressions, and eventually you'll do a problem and the answer is a whole new equation. So here we've got x squared minus 2x. This is an expression. Can you solve an expression? That's right, you can only simplify it. Remember, we simplify expressions, we solve equations. And we're going to start solving equations in the next lesson, so just, we're almost there. Oh, what about this one? This is kind of fun. We got variables all the way through it. Is that going to change the rules? No, it's not. That's right. So the first box, what do you think you should have? X times x. What should be in the next box? Well, somebody said xy. Is that correct? Well, let's see. No, it's almost correct, but it's x times negative y. Once again, let's go ahead and circle that little negative sign so we just remember it's there. Now, what's x times x? Good, that's x squared. Then what's x times y? That's right, it's just, in this case, negative xy. And keep in mind, this right here, this negative xy, that is a term. because it's a product. A product it's a term, or a term is a product. And here we've got x squared. Do these terms, do they have the exact same variable raised to the exact same power? No, they don't, because here you got x squared. Here you got x to the 1, and there's no y here. So what's the only thing we can do here? That's right. The only thing we can do is write it as an expression of x squared minus xy. All right, so now it's your turn. Kind of pause the video, work through these problems, and when you come back, I'll give you the answer. Okay, welcome back. So the first one, you have 2 times x, which is 2x. And then what's positive times a negative? Well, that's a negative answer, so that should be -4. Next one, we have 5 times x, which is 5x, plus 5y. So you should have got 5x plus 5y. What's 8 times 2? So right, 16. Then what's 8 times 3? 24. So that one should have been 16x plus 24. And then the last one is just this right here, right? It's the only one that's left. But a positive 5 times a negative 2 is a negative 10. Negative times a positive is a negative. So 5 times 3 is 15. In this case, it's going to be a negative 15. So we have negative 10x minus 15. Some more practice. What's different about this one? That's right, we got more variables. Is that going to change anything? No. All right, so work these on your own. Come back, pause the video. When you come back, I'll give you the answers. Which is going to be w squared. And then that's a negative, so we've got to have a negative in our answer choice. So what's 2x times w? That's right, that's just going to be 2xw. So we have 2xw. Even though this looks like you've got 3 numbers here, this is negative 2xy, that is still considered just one term because it's a product. It's multiplication. So that's still one term. So this right here has 2 terms. And eventually you're going to learn this is called a binomial. You don't need to know that for today, just a little foreshadowing. Here, you've got x times x squared. What's that got to be? That's right, it's got to be x cubed. Then what's negative 4 times positive x? That's right, negative 4x. So you should have gotten x cubed minus 4x here. Negative times a positive is what kind of number? That's right, it's a negative number. What's 8 times 2? Good, yeah, you guys are getting it. So you got negative 16. What's a negative times a negative? Oh, that's a positive. So we've got a mistake in our answer key. But you know what? We're going to fix that. We are going to fix that. So that's a plus 24. You get extra points if you saw that before I did. So that's plus 24. Then you got a negative times a negative, which is a positive 10. And then a negative times a negative 3 is a positive 10. So our final answer here has got to be 10x plus 15. And then I'm probably going to fix that on the PowerPoint before I publish it. So if your PowerPoint looks slightly different, that's what happened. I made a mistake and I fixed it. So here's your exit slip. Simplify these and think about what you learned about the distributive property today. So we got 20 for the first one. So you got 3x squared minus 2x for the last one. And finally, if you're double checking your work, last one should be negative 18x plus 27. and tell me, what did you learn? If you're online, just put it in the comment section. Our next lesson, we're going to learn how to solve equations. We're going to start with simple one-step equations, and we're going to move into things that are more complicated. So give you something to look forward to.